to you all. And on behalf of our institute, I would like to welcome you all to our today's webinar event. Today we have with us Dr. Rodrigo Pérez Fernández from CEng Shipbuilding, Spain, who will be discussing with us on the topic from paper design to digital revolution in the shipbuilding CAD industry. A few words about the speaker. Dr. Rodrigo Pérez Fernández is a professor at the Marine Engineering School of the Technical University of Madrid, and he is lecturing in shipbuilding history, gas and steam turbines, as well as other subjects. Combining his ability at the university, he works for CEng, a Spanish engineering company, for the last 15 years. Currently, he is the head of naval shipbuilding area at CEng, and in the past, he was the CAD and PLM consultant and project manager working in different projects around the globe. He has published several books and written more than 100 technical papers in marine engineering. Let's welcome Dr. Rodrigo to deliver the presentation. Over to you, Rodrigo.
Thank you very much, Biju, for your kind introduction. It is my pleasure to carry out this presentation for the IMarEST. I hope that all of you can see nicely the slides. The times that are changing is a song written by Bob Dylan and released, if I do not remember wrongly, around 1964. The song was written as a deliberate attempt to create an anthem of change for the time. And today, probably this is more important than yesterday. We are living in a continuous and fast technology evolution. Maybe this evolution goes faster than our capacity to assimilate what can do with it. But the potential is clear, and the future will be for those who identifies the right technology with the right application. In this information time that we are swimming, we are literally swimming in an ocean of structured and unstructured data, and thanks to the evolution in the telecommunications technologies, all that information can be used from everywhere. But information means nothing without the capability to analyze, extract conclusions, and learn from it, which is why the technologies like treatment of big data or the artificial intelligence are crucial. Imagine how these technologies shall allow to engage the design of a part or any concept by applying rules which will facilitate the design significantly. How the integration of the validation of the structural models by the classification societies will be linked directly by cloud applications. Imagine all the benefits of this example that can be implemented thanks to the potential of these technologies. The way we work with CAD tools, with the software, is also changing thanks to the ubiquitous access to the information and the different hardware available to exploit that information. Augmented, virtual, or mixed reality, but not only the way we work, but also the way we interact with the software is changing, with technologies like natural language processes that allow to have a direct conversation with the applications. The concepts that are absolutely clear from now to the future in shipbuilding is the use of a data-centric model and the concept of the digital twin, a real and effective synchronization between what we design and what we construct by covering the complete life cycle of the product thanks to technologies like the IoT, Internet of Things. Nowadays, it is unimaginable to work without software in shipbuilding. Ease of design with design rules embedded, speed of design, use and reuse of information, many technologies. It is expected that in the future, the software will advance further and allow greater information management through new improvements. There are several scenarios of improvements explained in this conference for the next year. Some of these improvements may seem unrealistic in the short term, but reality often exceeds expectations in any field, and probably more in technology. In this slide, I would like to mention a quote from Antoine de Saint-Exupéry. It means that the best way to motivate people to do a good job is to get them to share your view. And if we want to improve the shipbuilding industry, we need to share the main ideas. So it's very important that all the people that will be part of this revolution will be motivated. So the shipbuilding industry has varied widely through history. One could argue that the first shipbuilders were the Egyptians due to the evidence of bundle raft and big plank boats, first using CU joints on the key of ships around 2600 before Christ. All Mediterranean civilization, Greeks, Romans, were subsequently improving their fleets, and they were established as naval and military powers. These techniques were perfected by the Venetians from the 13th centuries to the 16th century, when they began to define the form of the frames in terms of tangent continuous circular arcs, V-arcs in modern dialect. A V-arc is a model commonly used in geometric modeling and computer graphics. It is composed of two consecutive circular arcs with an identical tangent and the connection point. The ship hull was obtained by burying the frame shapes along the keel, an early manifestation of today's tensor product surface definitions. In the late 19th century and early 20th centuries, the frames of a steel ship were stood up on the keel like those of a wooden ship, and the plates attached later. Frames had to be shaped to match the curves of the hull design. Each one was heated in a forge and then hammered or jacked to match the shape of its templates. In late 19th century, it was not easy fairing the hull. Flexible sticks called buttons were used for fairing the lines. Finally, the lines were transferred onto full-size molds patterns, so from thin wood. Throughout the first half of the 20th century, ships were getting bigger, so it was necessary to work on larger scales. The templates allow working on different scales, such as the widely used 1/10 scale. But with growing size, the moment came into was not longer practical to use templates. This happened at the time when the first computer came to our industry, promoted the development of ship design CAD systems. Traditionally, most shipbuilding CAD systems focus on hull forms definition, naval architecture calculation, and structural design. This changed when new challenges in shipbuilding demanding closer coordination between hull structure and outfitting obliged marine suppliers to devote special attention to this matter. Some softwares started the development of particular outfitting tools. Others limited tried to find a closer integration with existing plant design-oriented systems. Problems to be solved, regulations, working procedures, nomenclature, production information are so particular to ship design that it is very convenient to have a dedicated software rather than to apply or to adapt an existing one. As time went by, outfitting tools have been increasing the scope of support. Today, tools usually include particular environments for equipment, modeling and layout, piping and heating, ventilation, or ventilating and air conditioning. That's routing, definition of auxiliary structures, foundation, gratings, ladders, and definition of all distributor supports and hangers. In some cases, also electrical and accommodation aspects are considered. Particularities of outfitting design require to work in a pure 3D environment and with a friendly and suitable user interface. But new developments in outfitting tools have been always handicapped by the ability technology, hardware, graphic possibilities. Nowadays, it is commonly assumed that outfitting tools should be able to work in a solid visualization method with huge amount of information on the scene being dynamically handled. So to be able to understand, when I mention Industry 4.0, how the Industry 4.0 becomes today buzzword, a look at its predecessor might give us a perspective on how this revolution in particular is different. So the first industrial revolution arrived in Britain, introducing machines into production by the end of the 18th century, between 1760 to 1840. This includes going from manual production to the use of steam power engines and water as a source of power. This helped agriculture and the term factory became a little popular. One of the industries that benefit a lot from such changes was the textile industry and was the first to adopt such methods. It also constituted a huge part of the British economy at that time. The second industrial revolution dates between 1870 and 1914, although some of its characteristics date back to the 1850 and introduced pre-existing systems such as telegraphs and railroads into industries. Perhaps the defining characteristics of that period was the introduction of mass production as a primary means to production in general. The electrification of factories contributed hugely to production rates. The mass production of steel helped introduce railways into the system, which consequently contribute to mass production. Innovation in chemistry, such as the invention of the synthetic dye, also marked such period as chemistry was in a rather primitive state then. However, such revolutionary approaches to the industry were put to an end with the start of the First World War. Mass production, of course, was not put to an end, but only developments within the same context were made, and none of which can be called industrial revolutions. The third industrial revolution is much more familiar to us than the rest, as most people living today are familiar with industries leaning on digital technologies in production. However, the third industrial revolution is dated between the 1950 and 1970. It is often referred to as the digital revolution and came about the change from analogical and mechanical systems to digital ones. Others call it the information age too. So there are many information that we can share regarding this. This third revolution was and still is a direct result of the huge development in computers and information and communication technology. Finally, the fourth industrial revolution takes the automation of manufacturing processes to a new level by introducing customized and flexible mass production technologies. This means that machines will operate independently or cooperate with humans in creating a customer-oriented production field that constantly works on maintaining itself. The machine rather becomes an independent entity that is able to collect data, analyze it, and also advise upon it. This becomes possible by introducing the self-optimization, self-cognition, and self-customization into the industry. The manufacturers will be able to communicate with computers rather than operate with them. All of this will be possible through the artificial intelligence, for example. So the Industry 4.0 transformation implicates a huge collection of interrelated and joint technologies, which can be analyzed independently, but must be applied as a complete integrated implementation in each industrial field. Moreover, in the computer-aided design, manufacturing, and engineering. From now on, I will refer just a CAD development industry. Each technology is exposed a set of boundaries which cannot be differentiated evidently from its neighboring technology. Virtual reality, the augmented reality, or the mixed reality are closely associated to the digital twin and interconnected with the big data, which is produced by the CAD tools and all surrounding solutions, which apply some cloud edge fog computing to this data in a merged technology between the finite state machines and artificial intelligence cognitive processes. To perform in an agile manner all this computing, it required a network which support different connection ways to add special devices. For example, the Internet of Things, which can access to the data created and modifying it in a different layer, which affects to the basic information layer created by the software in the shipyard. This network should be secure, but open to allow distributed work, which must be a step control in a manner that records any modification of each working step done in an open, transparent, trust, and non-modifiable working method for all actors involved in process, like shipyard, engineering offices, classification societies, ship owner, and the rest of the partners of our industry. Results of the design should be easy integrated with future building ways like 3D printing, generated printing orders directly from the CAD model. Shipbuilding engineering phases involve design and production, but an integrated Industry 4.0 software should also be involved in operation and maintenance. When, for example, I have many examples, when a ship comes for a reparation, sometimes the model is not available for this operation of maintenance. In reparation and maintenance steps, replicating the full, for example, engine room or any other local in the CAD system will be a nightmare unless the CAD tool has an artificial intelligence processing toolkit, which from a cut of points can recreate the CAD equivalent items, which can be converted with a minor user intervention and lesser as the artificial intelligence learns in a software integrated and full modifiable design. So after the review of all of these technologies, it is possible to have an idea of the magnitude and complexity of the changes that the Industry 4.0 is demanding. In most cases, it is an avoidable step that must be taken to remain competitive. But with the adoption of only a part of what is exposed here, it could mean a too risky and complex step that should be studied carefully before taking any decision. Some of these technologies are in early stages for industrial implementation, but it's important to be aware and analyze what can offer and what can be useful for each case. Most of the different technologies exposed in this slide are well known since long, but the true potential came a few years ago with the improvements in the communication infrastructure. That is why a concept like digital twin is something that seems reachable. Now with the 5G, it is expected that the IoT will grow in an exponential way and its true potential will arise, which will also mean the digital twin impulse. As I mentioned in the slide appears the technologies which I consider will bring a bigger added value for the shipbuilding. So there is a huge volume of information available for a correct design and building of vessels and shipyards. It is important to expose that the context where all this information is, from one perspective, really complex, given the number of regulations, guidelines, and at the end, rules that can be applied when designing a vessel or a shipyard. However, seen from a different perspective, it becomes a huge opportunity to exploit all this information in a much more intelligent manner. The aim of this conference is providing a better understanding of what it means by intelligent manner. So there are a number of concepts that coexist and very often lead to certain level of confusion. Data, big data, analytics, predictive analytics, prescriptive analytics, all in all, they are embedded into a wider concept of cognitive. Besides, it must be conscious of the fact that information is not yet limited by the list of information depicted before. What is declared in that piece is limited to what is called structured data. However, there are numerous papers, many papers, to the fact that this structured data covers only a 20% of the information available for us to use. It is also a reality that there is a huge and continuous generation of information that doesn't reside in such a structured source of information. For example, the manuals from the shipyards, guidelines, reports, contain huge volumes of information that is actually embedded in pieces of information that is commonly called documents. All these sources of information documents currently provide an enormous source of data that can be extracted for those encapsulated binders that is known as documents. So I'm not going to enter in more detail regarding this because relative recent evolution in computing capacity, formerly named high capacity computing, brought a key new capabilities that jointly with pure data management have carried out a much more powerful capacity to manage this information. But as I do not have many information to wait here, I will pass to the next one, link to the 5G network. So it can be affirmed that the combination of the wireless evolution with the new 5G network and so of Industry 4.0 will mean a turning point as the 5G technology will solve many of our problems and will solve problems that haven't been able to solve properly up to now and have meant an obstacle for the evolution of the future factory, for the future shipyards. 5G promises to be the answer in terms of flexibility and versatility in Industry 4 or that Industry 4.0 demands. But what will be the advantages that 5G technology will provide us, will give us? Enhanced mobile broadband speed and more capacity, up to 100 faster than 4G. Ultra reliability and latency will be less than a millisecond. Massive matching type communication that can support a very high density of devices. An architecture more open to third parties through APIs, for example. And finally, a network slicing. This concept that consists in a partition of the same physical network into multiple virtual networks, each one optimized for different applications, will save cost and have a faster time to market. So other technologies that we are implemented into the software, into the shipbuilding industry, is the virtual and augmented reality. Both are technologies that cannot be considered as new, especially the virtual reality, whose origins go back to the Second World War. Until not long ago, the use of virtual reality in industrial area was something very rare due to, among others, to the high cost of this technology. But up to now, and thanks to the recent progress in computer science, miniaturization, storage, graphic processing, and the new high-resolution screen, as well as technology, is cheaper. So the virtual reality and augmented reality has revived. Today, and thanks to the possibility of using smartphones, for example, all of us, we have smartphones for watching, interact virtual reality environments or visualize augmented reality content. These technologies are available to everyone without need of having a very powerful device. Another sector that drives this type of technologies are the video games world, creating increasingly real environments in which the user can feel really immersed thanks to the virtual reality glasses, and the tracking system allow a deeper immersion, allowing to transfer their own individual movements, action in real environment, links to the action in the real world. Besides, virtual and augmented reality also coexist with mixed reality, hybrid reality, and merged reality. These concepts are newer than the preceding, and in which potential is out of question, consists in the combination of the physical world and the virtual world in a way that all of them coexist. This assumes that in these types of environments can happen a complete interaction between reality and virtual environment. So nevertheless, the augmented reality is the technology that may seem to have more power in industrial sectors, providing or proving in the cases it has been implemented that significant error reduction, increase in productivity, drop in employee injuries, reduction of ergonomic issues, favor collaborative environment, and finally, improves efficiency. The use of these technologies is more present and every day more important, for example, in other technologies like the automotive and also in the aerospace industry. In other industries, the progress is slower, as for instance, in the shipbuilding, our industry, which we are quite traditional. But for digital twin, virtual reality and augmented reality comes along, and digital twin is an unstoppable wave in Industry 4.0 and what we call the shipyard 4.0. So linked to that is the robotics. So the robotics aims at the design, construction, and operation of robots in its broadest meaning. Many technologies are involved in the development of machines designed with the aim of replacing humans in some of their activities and the technological advantage. We are undergoing mean that more and more activities carried out by humans can be executed by robots. This fast evolution makes increasingly frequent to debate the presence of this type of machines or systems and the substitution of human action by the action of the robot. More efficient, faster, free of errors, no need to rest. There are many incentives offered by the incorporation of robots in our shipbuilding processes. Robots have been around for a long time and are especially susceptible to be used in repetitive processes or following some kind of more or less complex pattern. Especially useful are those that allow the humans being to be freed from dangerous tasks, such as carrying out work in hazardous environments or situations. Activities in industrial environments, such as a shipyard, are often dangerous, and the use of robots to carry out such operations is desirable. With the arrival of the artificial intelligence, a strong change has been made to robotics, allowing it to extend its field of action also to situations in which decisions must be made based on the control conditions that the robot is able to detect with its sensors and elaborate a response to that situation on its own. The application of robots are huge and growing as technology and material advance, but some of the main applications are robots for military applications and robots for industrial applications. Linked to that, within the industry, the automotive sector is the one that most often uses robots in its production plants, reaching, in some cases, such high level of automation that manpower hardly participates. So, as I mentioned, the artificial intelligence is a key actor in all this Industry 4.0. So, there are many examples where we can apply this artificial intelligence, no? And one of them could be the control system of a ship. So, for example, the control system in the ship can include some artificial intelligence predictive processes integrated in the bridge overall control system, which help to reduce the consequences of maintenance operations from doing in the correct time, as well as delaying or skipping them. These processes or this procedure applied is included in the edge flow computing method that I explained at the beginning, due to only involves the ship inner communication network, delaying the massive download of operation data upon arrival at port. During navigation, data transfer should be only applied to critical operations. Navigation data can be also useful in design and production phases to correct some processes in order to obtain more efficient systems and more efficient designs. This is only possible applying some artificial intelligence process to this data, classifying, processing, and getting some results. This working methodology, to be deeply profitable for both actors, requires a joint venture between ship owner and shipbuilder. Artificial intelligence processes based on navigation data in the multi-boat paradigm can obtain information to improve design and production processes, which can be applied to the current series or an evolved variant of this vessel type or other ones. Ship operation phase is not the only one which produces a set of big data to be processed by an artificial intelligence system. Is the production phase, some calculus can be done in the workshops or even delegated in a cloud system to be distributed. This data in a CAD artificial intelligence tool, in a CAD artificial intelligence software, can be classified, generating working sequences, design automatic checks, and automatic design processes. Now, setting the focus on the designer, sometimes for the tight schedule or for the start-stop working requirements of the design office, like for example, meetings, designer doesn't have much time for its principal task, create full effective designs, which requires concentration and calm. These problems can be solved by the artificial intelligence, applying some design rules and exposing a bunch of effective solutions, delegating the final decision on designer by helping discarding a big group of previous solutions which have shown, or for example, some problems, for example, the lesson learned. At this point, some skeptic people can think artificial intelligence is going to substitute designers' work, but artificial intelligence, in my opinion, is going to augment, increase the capabilities of this designer, making work less stressing and more efficient, and all available artificial intelligence processes can be applied in a software to help to support designer art in a greater way. So as I explained, I have just a brief time to explain all of these slides. I would like to mention just what is different meanings of the artificial intelligence. Really, the main idea of the artificial intelligence is to enable computers to mimic the human behavior. In order to do that, we need to use certain paradigms. Between them, we have the machine learning and the deep learning. Here I have some of the definition of these two aspects. But probably the artificial intelligence requires the natural processing language, I have mentioned at the beginning, the computer vision, the robotics, the sensor analysis, the optimization and simulation. The machine learning will decide or will require different aspects: support vector matching, decision trees, base learning, key means clustering, associated rule learnings, regressions, and finally, the deep learning will require certain neural networks, can be convolutional, recursive, long short-term memory, and finally, the deep belief network. So there are many universities that they are carrying out studies, implementations, research on all of these topics. This is a huge amount of information. This is a huge world. And for the younger that they are studying now in the university, I think that these technologies open a huge opportunity for you to study and to implicate in the shipbuilding industry. So finally, I would like to enter in another technology that has been growing exponentially, that is the laser scanning. So the 3D printing and laser scanning are technologies able to reproduce with more or less precision a model or real environment in a digital environment through mapping to a physical version. The most modern scanning techniques combine the laser scanning for the 3D points acquisition and photography to assign colors to those points and reproduce accurately the objects. Depending on the scanner type, laser characteristics, boundary conditions, especially light and physical characteristics of the scan object, influencing the quality and accuracy of the captured cloud of points. But if conditions are suitable, precision should be more than enough to give valid solution for industrial application. Nevertheless, some other issues have been taken into account when scanning. It can only be scanned what is seen by the scanner. Having into account the previous, it is not possible to scan the inner part of an object. In a first phase of scanning is to obtain a cloud of points, but once done, the cloud must be simplified, deleting unnecessary points. Archives generated by the scanner are very simple, but the weight can be of importance. So the files might be difficult to manage. And finally, the final problem with the laser scanning is that after cloud simplification, these points are usually helpful if they are transformed in surfaces or volumes, which can be worked. For doing so, as in the point simplifying, software is available, in many cases provided by the scanner manufacturers, that uses algorithms capable of assist end user to find certain basic volumes and surfaces. For example, the walls or spheres. As can be seen, laser scanner usage is not easy, especially the part that refers to optimization of the cloud points and surfaces and volumes conversions. The photogrammetry will be a solution. So the process isn't easy as well. It requires a camera specially calibrated. Capture processes are similar to laser scanner, and also the conditionals as the post-process until the 3D object is obtained. So in spite of difficulties and complexities of the process of the laser scanning, these technologies are very useful, particularly could have a great interest for three aspects: for inspection and supervision processes, to perform comparison between the real model and scan model, something that it is used in industries such as automotive and aerospace to detect the deviation from the original model, especially in those cases in which the accuracy in the manufacturing is crucial. And finally, the reverse engineering. So the reconstruction of a digital model, starting from a real model with these techniques, makes sense if combined with the 3D printing, and it eases to the reproduction of pieces that need a quick repair in the cases that the reception of the original piece cannot be wait from certain supplier. The possibility of scanning a problematic element and combine the scan with the modeling of a solution that fits perfectly with the scan for later printing of the solution is one of the biggest advantages that offer this technology's combination. Once provided this solution and being tested in situ, it is possible to create a piece manufactured by traditional methods by a supplier if the quality of the printed doesn't allow its use in operative conditions during the required period. 3D scanning has many other utilities in the software, digital twin and simulation. Today, it is not unusual to find a combination of software models that integrate geometries obtained from 3D scanning. This is useful when modifying an engine room, for instance, scanning it and performing the redesign based in the 3D cloud of points. And finally, because I am 4 minutes to the deadline of the presentation, I would like to conclude that there is another important piece of the puzzle that has not been mentioned yet, that is the security, veracity, and trust in the data transaction between all the different participants, ship owners, shipyards, technical offices, universities. Cloud and security are two pieces of the game, and without them, all this ecosystem will never work. Data transactions should be guaranteed, and all the steps should be tracked from the first step to the last one of the process thanks to the blockchains. This data-centric model will be complemented with big data, analytics, and artificial intelligence. Extracting conclusion from that big amount of data acquired from IoT devices, for example, making possible a better maintenance thanks to the capability to predict failures or detect problems in early stages, as well as the consequences of those problems, and learning from manpower that works in our industries by analyzing the activities in order to process all that information and be able to suggest better practices by detecting bottlenecks and possible solutions. So as I mentioned before, repetitive tasks and dangerous activities that nowadays are carried out by labor force can be replaced in the future for sure, or at least supported by robots, which means an important change for the companies and the people that works there. But this transformation is unstoppable. New jobs will be created and new profiles will be necessary for those jobs that could be replaced totally or partially with robots will disappear. People should react to these new conditions and adapt. The implementation of robots and autonomous vehicles in our industry will also mean the presence of new tools that will improve working conditions for current workers. But it is necessary an adaptation to all these new technologies, and sometimes it will not be easy. Shipbuilding is an industry that could take advantage by using them. By depending on the particularities of each shipyard, these technologies will be more or less easy to implement, and even if it is feasible, the decision should be taken from perspective, because physical robots and autonomous vehicles need special conditions to work. As I mentioned in the last slide, new materials and 3D printing techniques will have an important role in the future of shipbuilding, as already been demonstrated in other industries, such as the aeronautics and automotive. But in shipbuilding, there are interesting challenges. The use of 3D printing on board, for example. In the middle of all of this ecosystem, we will find a 3D model created mainly with CAD tools, and this means that the importance of the CAD will be even more important or more capital than today. The interface between the 3D model and the rest of the industry is the digital twin, the link between the reality and the virtual world, both living concurrently during the evolution of the construction and extending this world of possibilities to the entire life cycle of the product. So the software as an important part of all of this environment should also evolve to be easily linked to these technologies. But also it's important to be adapted to new generation of users that demand a different kind of interfaces and workflow, and this will be required an important effort. So this big world is now open, and shipbuilding is starting in it. but the potential is clear, and to remain competitive, it is mandatory to study how these technologies can improve the benefits by upgrading processes, resources, workflows, cooperation between the different stakeholders in the shipbuilding industry. The tools are here. Now it is necessary to study and analyze our particular case. Finally, just to mention that there is not a global solution for all industries. There is not even a global solution for a particular industry, but the digitalization, the fourth industrial revolution, is on hand, and it is mature enough to start implementation and be part of our strategy for the future. So thank you very much for attending this conference. Please feel free to ask any question you may have. Thank you very much.
Yeah, thank you, Dr. Rodrigo. So we got a few questions on the line. Okay, and also for the audience, you can type in your questions through Slido using the hashtag design. You can type in your questions, please. And we'll go for the first question. What is your view on the investment and returns? Or have you done some cost benefit analysis for a shipyard to invest in ship 4.0 technologies?
Yeah, it's a great question. The first thing, always that we want to implement something, and probably the author of the question knows very well, is to do a ROI, a return of investment. So it's important to do not try to apply all the developments, all the different technologies at the same time. It's important to analyze first what the different industries or what the different technologies for the different industries applies better for us. So it's important to decide if now is the augmented reality, we will try to do a use case of artificial or augmented reality or artificial intelligence on the workshop. So it's important to do this return of investment, this analysis, step by step. So I think that probably, as I mentioned, the shipbuilding industry is quite traditional, and all the implementation in the past has been done later than other industries, as they already mentioned, automotive and aerospace. However, I consider that there is specific technologies that can be supported our industry, no? As for example, the artificial intelligence. So in terms of the cost, I think that probably right now the cost is higher than it is expected in the next year, because right now the technology is at the beginning, and as you know very well, at the beginning of any implementation, the costs are higher. So it's important, probably my recommendation is to study carefully each of the technologies and also participate with the crucial stakeholders in order to minimize the cost of this implementation.
Yeah, thanks for that. The next question goes, have manufacturers begun to apply intellectual property rights protection to protect against 3D scanning and additive printing copying?
Yes, again, it's a great question. I do not have the solution right now. I think that the legal departments, they are also investigating how to be able to in certain way stamp certain level of copyright in all the different aspects. We are at the beginning of this evolution, no? Probably we will find certain problems, no problems. I do not like to call problems, opportunities, no? So I think that this is a specific aspect that needs to be analyzed with experts, no? And the legal part is not my expertise, but for sure we will find a solution and a specific point that where the people will feel, in a certain way, happy with the production. But it's true that this is one of the risk opportunities that our industry is facing, not just our industry, all the industries. The concept of the 3D printing and the copyright of all the elements regarding that.
Yeah, thanks for that. The next question is, could you please elaborate more on how you interpret the expression a digital twin, and who would be the owner manager of a digital twin?
Okay. Again, all the questions that you do are spot on. Uh, my point of view is the digital twin is not a unique digital twin is not the solution for our industry. The shipbuilding industry is quite complicated, but do not think that is more complicated than other industry. It's quite special. So we are building ships. It's like bigger and bigger cities where you have everything. You have a system of systems. So it is quite impossible that you will be able to get a unique digital twin for everything. So right now, what I think is we will be able to manage a series of digital twins. No, so as regards who is going to pay, okay. So it's important that all the partners, all the stakeholders in our industry collaborate. So if something is telling us the industry 4.0 is that we require collaboration. We require to talk each other. It means that if, for example, in my ship, I have everything sensorized, but nobody can read my data, it's you do not have anything. So it's important that suppliers, private organization, public organization, all the stakeholders speak and talk in the same language. So it's a question of collaboration. And this collaboration means that everybody needs to collaborate with time, with man hours, and obviously with cost. So it's important that we start cooperating. So right now there are many suppliers, for example, main engines, gas turbines, that they are able to produce all the data regarding the maintenance predictive or all the different data that are collected by the sensors. But now this information needs to be understandable by the rest of the partners in order to find, in certain way, what is the best alternative in order to decide what to do with the data. So I hope, probably we can open like a more open discussion, because I think that probably many of you have different opinions regarding that. But in terms of the digital twin, I consider that we will have several digital twins. We will have a system of systems, and the more important is to collaborate between the different stakeholders.
Yeah, thanks for that. Yeah, if you have any more questions in the audience, please type in, use the Slido. And in the meantime, from my side, I am thinking, you mentioned about artificial intelligence and deep learning techniques. So where do you see the future of having the deep Q learning techniques in the CAD in our shipbuilding industry in the future? And
The
where we are,
artificial intelligence, understood. The artificial intelligence is an unavoidable step that must be taken to remain competitive, because this is clear. This technology are in an early stage for industrial implementation, but it's important to be aware, analyze what can offer and what can be useful for each of our use cases, no? Because in our industry, we have different stages. So from the basic design to detailed design, production, operation, maintenance. So it's important to find the best option, to the best alternative, to the best or to each of the different stages. So in this information era where we are living, it is not difficult to be involved in that. So due to we are living in a continuous and fast technology evolution, and it does matter the age, I think. So maybe this evolution goes faster than our capacity to assimilate what can do with it, no? But I think that the potential is clear with this artificial intelligence, and the future will be for those probably students right now in the universities who identifies the right technology with the right application. So it means that there are many aspects, many pillars of the artificial intelligence. Natural language process is one of them, machine learning, deep learning, and it's fantastic that the new generation start working on that and try to elaborate better software, better utilities, better implementations that can react to the demand of the artificial intelligence. But for sure, the artificial intelligence will be in our present dates in the future years.
Yeah, thanks for that. Any more questions from the audience? Yeah. Okay, I'm just waiting for any more questions. I can't see on screen. And while we are waiting, okay, so regarding the for the training the models and all, how much data will be required for, do we need to have quite a lot of history to be fed into that models to get that get the appropriate results what we are looking for?
So there are I understand.
Yeah.
I think that there is there are two types of data. There is the data that you designed on the 3D model, on the CAD, on the software, and there is other data that is the data that we collect from the use of tools or from the use of the machines. No, for the second one, we never know about what is the minimum data that we can receive. The important is to receive good quality, good data. No, so it's important that the sensors, everything, all the sensors that we have placed on the different equipment provide us the correct information. And the second type of data is the data that we introduce to the software. I think that this is the question that is asked. It depends of the type of shipyard, the type of the vessel, the boat. So it is not the same that you design a commercial vessel, or you are designing a boat, or you are designing a frigate. No, so it depends on the type of the vessel. Why it depends? Not because one is more difficult than other. It's more for the time that you have in order to design the vessel. So you know that there are commercial vessels that are obliged to be designed and construct in less than 1 year, in less than 6 months, in less than 3 months. So probably you do not have enough time to implement all the data that, for example, you would like, no, because the time is restricted by the ship owner. So depending on the type of shipyard and the type of vessel, we have different options in order to generate information. For example, for a commercial vessel, probably they will just require to model the cable tray or the space envelope of the cable tray, and they do not model anything else. But there is another shipyard that they decide to model each of the cables on the cable tray. So this is something very particular. As I mentioned, there is not a global solution for all the industries, and not even a global solution for a particular industry. So it is important that we collectively analyze each of the use cases and each of the shipyards, because not all of them will work on the same way.
Thanks for that. So also there will be a learning process in that. That is, if there is any mistakes, the models will be learning from the mistakes, and that will be fed back.
But not just that. It means that, for example, when you are working, because we are working in this, we can say, in the beginning of the artificial intelligence in the civilian sector, no, we can, or in this case, we have developed like a tool that we call assistants, no, the CAD assistants, the foreign assistants. So this artificial intelligence software is true that learns from previous mistakes, but not just that. It is also learning from your decisions. So sometimes you are designing something, probably imagine the naval architecture part, you are doing some damage stability criteria, and the software or the artificial intelligence software is telling you, you should apply this criteria because this criteria feels better than this other, or you should do that because the classification society indicates that the thickness should be this one and not this other one. So sometimes the designer is, is the experience of the designer, the know-how of the designer, who sometimes decide, no, this is not like this. This is like this because I know how to do it. Many times, the classification society provide regulation rules, but these rules sometimes can be improved by a designer that knows how to do it and can not complain, but discuss with the classification society and say, I have decided to change this for this other. And the classification society accept, no? So the artificial intelligence software will learn from that decisions. Because remember that it depends on what is the information that stay on the corpus of the artificial intelligence. It means like the brain of the artificial intelligence software. You have the regulations, you have rules, but also you have the know-how of the designer. And this is very important because the designer has a lot of experience, and the experience is probably the top of the knowledge. And this knowledge is very difficult to put on a document, no? And probably the artificial intelligence software will be able to read or to retain this information for the industry, for the shipyard in this case.
That's great. Thanks for that. There's one more question online. Can you please inform which Spanish yards have already implemented Ship 4.0 technologies or is in the process of implementation?
Yeah. As far as I know, because I cannot specifically talk about any of them, okay? Because not just Spanish, there are around the globe, there are many shipyards that they are implementing this type of technology. I am not telling that specifically technologies about a specific product because this is not something commercial. This is more general. There are Spanish shipyards that they are implemented slowly, slowly, like the rest of the shipyards around the globe, different Industry 4.0 technologies. It's true, there are shipyards that they are implementing from Google Glass, like some Google Glass that can identify, tag the different stock of the material, implemented digital twin, but we are in the way of implementing. So there are many companies around the globe who are implementing this type of technology. As I mentioned, the more important is the collaboration and the collaboration between universities, companies, in order to provide to the sector the best tools. So I am sure that in every country where the shipbuilding is a huge sector, all of them, they are already in the way of implementing these technologies. Of course, not just software, robotics, 3D printing. I think, if I do not remember wrongly, it has been already 3D printing propellers, 3D printing engines. So I think that these technologies are on the way. So I think that we're in a very good moment and in a huge opportunity for all of us to participate. No?
Yeah, thanks for that. So there's one more question, and we are 2 minutes remaining. So just to briefly, if you can mention what software do you use to make your models? Like what to make a ship propeller model? What is the best software to do you use for analysis? Maybe a brief.
Okay, so it's important because there are software for 3D modeling. I mean, there are software for basic design, for detailed design, for production, for manufacturing, for operation, for maintenance, for analysis. So the question is regarding FEM analysis. So because there are many softwares on the market, so I think that all of them has good things, has pros, has contras. So I think with all of them you can manage. So depending on depending on what you are demanding, no. So yeah. Probably the software which we use for we can say detailed design and production is FORAN, but it is important to know what is the type of analysis that he's mentioned.
Yeah. All right. Thanks, Dr. Rodrigo. Actually, I just want to wrap up now. Thanks very much for your very informative and enlightening presentation. And on behalf of the institute, I would like to thank you for your presentation. Thank you, and thanks to all the delegates watching our live stream, and for your participation and all your inputs. Thanks very much, and enjoy the rest of your day. Thank you very much. Bye bye.